If you were lucky and your parents were willing to let you stay up late, some of you may have been able to catch a glimpse of the lunar eclipse this past week, where our very own planet blocked the light from the sun from reaching the surface of the moon. In perfect viewing conditions, this turns the moon red in the night sky, a phenomenon known as a blood moon. Lunar eclipses are one of two types of eclipses that we see, with the other being a solar eclipse where the moon blocks the light from the sun from reaching the surface of Earth. From the surface of Earth, these events are hard to miss. It's almost as though we could fly up there and block the sunlight ourselves. Realistically, however, these events happen on massive scales over even larger distances. Let's start with some distances we can use as a baseline. We can pretty easily get a feeling for how big the Earth is. That makes sense though. We live here and have an understanding of how far everything is. We can imagine being on an airplane and flying anywhere we desire on the order of hours. For example, at max speed, an airplane can fly around the world in 40 hours. Something I'm sure all of us can agree is pretty long, but doable. However, the fastest rocket can do it in just 90 minutes. The fact that the moon is so massive and appears so much smaller in our night sky speaks to how far away it actually is. If we were to use the same rocket, the trip to the moon would take 3 days. These distances are often hard to grasp, especially considering the moon is the closest object in space to us. Today we will take a look at our own solar system in order to understand the size and distance of our sun and the 8 planets. We start with the sun, the center of our solar system and the source of life on Earth. At its core, the temperature of the sun reaches 27 million degrees Fahrenheit and lights up our entire solar system. The circumference of the sun, or the distance around, is 109 times the distance around the Earth. That means in our same rocket, it would take 7 days to fly around once. As the most important object in our solar system, we will talk about the distances of the planets in relation to the sun. So without further ado, let's jump on our rocket and take a trip around the solar system with Sammy and the rest of the SBS team, who will guide us through the distances using the Union College football field.
In this visualization, we will represent the planets and their sizes using various household goods. The first thing we will do is shrink the Earth down to the size of a cherry tomato, which is less than 1 inch in diameter. If we were to take a ride on our rocket starting at the Sun, we would first arrive at Mercury in 653 days. Mercury is the smallest planet at about 1/3 the size of the Earth. Here, Bianca holds a small pebble at the 1-yard line. As the closest planet to the Sun, Mercury has the hottest days with daytime temperatures exceeding 800 degrees Fahrenheit. Definitely not somewhere we want to stay for long, so let's move on to the next planet. After another grueling 485 days, we would arrive at Venus to find a planet even more inhabitable than the 800-degree days of Mercury. With a thick carbon dioxide atmosphere and clouds made up of sulfuric acid, temperatures on the surface of Venus remain around 850 degrees Fahrenheit. Venus is the closest planet in size to the Earth, and thus we represent it as a slightly smaller cherry tomato at the 1.5-yard line. Leaving just as quickly as we arrived, we would make the 403-day trip to arguably the best planet of them all, Earth. Earth is about 2 yards away from the Sun on our football field representation and remains the only planet that is able to support any form of life. From here, our travel time gets increasingly longer. The trip from Earth to Mars, which is the next closest planet, takes 780 days on our rocket, well over 2 years long. This places Mars at just under the 3-yard line, where we represent it as a marble, slightly smaller than the cherry tomato we have representing the Earth. Taking a close look at Mars, all signs point to the fact that the red and dusty wasteland once was filled with water that could have potentially hosted the basic ingredients of life. However, the only things that now occupy Mars are the robots sent by humans to explore its surface. This actually makes Mars the only planet that we know of exclusively inhabited by robots. From Mars, we take a long voyage of 5,342 days to make it to Jupiter, the 5th planet from the Sun. This brings us out to the 7-yard line of the football field. Jupiter is the largest planet in our solar system, which we have represented here by a basketball. Unlike the first 4 planets that we have visited, Jupiter and the rest of the planets in our solar system have no solid surface for us to touch down on. From our view in space, the most interesting feature we would see is the Great Red Spot, a storm over 3 times the diameter of Earth that has been going on for at least 357 years. From Jupiter, we fly for 6,301 days to reach Saturn at the 14-yard line of our field. Saturn is well known for its incredible rings that are even visible from the surface of Earth using an amateur telescope. These rings are composed mainly of water ice particles that could be up to 1 meter in size each. Similar to Jupiter, Saturn is a massive planet, here represented by a football. Saturn to Uranus. In total, this trip would take us 14,000 days, more time than our entire journey so far. This brings us all the way to the 28-yard line. While bigger than Earth, Uranus is much smaller than the previous 2 planets we just visited. Here, we represent it as the size of an apple. Even though it is not the farthest planet from the Sun, Uranus is the coldest planet in our solar system, with an average temperature of negative 330 degrees Fahrenheit. Finally, we make our journey to the last planet in our solar system, Neptune. From Uranus, this voyage would be the longest yet at 15,800 days, all the way to the 43-yard line on our football field scale. Neptune is slightly smaller than Uranus and still much bigger than the Earth. Here, it's represented as an orange. Being so far away from the Earth, Neptune is incredibly hard to spot, making it the first planet that was discovered using math instead of observations.
At this point, we have traveled 2,800 million miles on our very trustworthy rocket over the span of 44,000 days. This amounts to 120 years. While a rocket is not the fastest traveling object that we as humans have built, this is about how long it would take for it feasibly possible for humans to make this trip. The voyage would span multiple generations of people, meaning the passengers arriving at the final destination of Neptune would most likely never have stepped foot on Earth. Along the way, we have marveled at the great wonders of the planets and traveled deep into our solar system. Yet our solar system is just a small pebble in the vast expanse of our universe. Our entire solar system sits in the Milky Way galaxy, one of the countless other galaxies in our universe. We share this galaxy with other solar systems marked by their own sun-like stars. Most of all, we are surrounded by empty space. If we wanted to continue our journey past Neptune to travel to the closest neighboring star, the trip would take our fastest spacecraft 18,000 years. To another galaxy, it'd be another 749 million years. For now, these distances and time remain well beyond our reach in current technology. But who knows? Maybe one day in the way distant future, our relatives will embark on the trip of a lifetime, officially making humans a galactic species. For now, we aim to keep understanding the planets and objects in our solar system. As NASA heads back to the moon for the first time in 50 years, you can count on the fact that in a near lifetime, humans will walk on the surface of a planet other than Earth. To learn more about the solar system and to continue your trip, visit solarsystem.nasa.gov to experience an interactive and highly informative simulation of the voyage we just described.